Hi students, welcome to physics classes. Now in the point of public exams 2022-23 10th class, we are discussing 1 mark questions and 2 mark questions. In the first part we discussed heat and refraction of light at plane surfaces. Now we will discuss next chapter refraction of light at curved surfaces. Now in the curved surfaces, first topic, when light ray traveling from rarer to denser convex continuous surface, what is the relation between object distance and image distance? N2 by V minus N1 by U equal to N2 minus N1 by R. N2 by V minus N1 by U equal to N2 minus N1 by R. This is the relation when light ray traveling from rarer to denser convex continuous surface. Here N2 is the refractive index of second medium, N1 is the refractive index of first medium, V is the image distance, U is the object distance, R is the radius of curvature. Okay, now if the surface is plane surface, R becomes infinity, 1 by R becomes 1 by infinity equal to 0. So this entire term equal to 0. N2 by V minus N1 by U equal to 0. N2 by V equal to N1 by U. Not much important. Sometimes if a question paper is difficult, they may ask this type of questions. Next, lens. Here lens biconvex lens. Sometimes they are asking, draw the diagrams for lenses. Biconcave lens, plane convex, plano-convex, plane concave, plano-concave, concave convex, concavo convex. These are the different types of lens. Next, actually this lens we have taken from the sphere. From the sphere, one part we have taken in the form of lens. Now this sphere has center. Sphere has center. That center of the sphere which contains a part of curved surface. Center of the sphere which contains the part of curved surface is known as center of curvature. For this first surface, center of curvature is C1. Second surface, center of curvature is C2. Okay. Next, the midpoint on the lens or center of the lens is known as optic center. The distance between optic center and the center of curvature is known as radius of curvature. The distance between optic center and center of curvature is known as radius of curvature, denoted by R. Now for lens, if you send parallel rays, this is the line joining center of curvature and optic center. The line joins center of curvature and optic center is known as principal axis. These are the definitions, very important. Now if you send parallel rays to the principal axis, after refraction they will meet at one point. That point is known as focus. The rays which are parallel to the principal axis, after refraction meets at one point, that point is known as focus. The length between optic center and focus is known as focal length. The length between optic center and the focus is known as focal length. These are the important definitions. And center of curvature is also known, can be written as 2f2 f2f1. C1 becomes 2f1, C2 becomes 2f2, because focus can be written as f1 and this side focus is f2. Double of the focus is center of curvature. So focal length is equal to r by 2 or r equal to 2f. Radius of curvature equal to double of the 2 into focal length, or focal length equal to radius of curvature divided by 2. This is the relation between focal length and radius of curvature. Relation between focal length and radius of curvature. Okay. Next, sign convention. Sometimes sign convention also they can ask. We have rules for sign convention. That rules are enough. All distances should measure from optic center or pole. All distances should measure from optic center or pole. So whatever the distance here, whatever the distance we are measuring, that we should measure from the optic center. Now the distance in the direction of incident ray, for example, we can draw convex lens like this, convex lens, concave lens like this, convex lens, biconvex lens like this, biconcave lens like this. Now for example, this is the principal axis, here object is placed, this is the direction of incident ray. So the distances measured in the direction of incident ray positive, opposite to the incident ray negative. So here onwards we will start, this side all are negative, this side all are positive. So here onwards we should start. If you measure like this, in the direction of incident ray. If you measure like this, opposite to the incident ray. Third one, above the principal axis is positive, below the principal axis is negative. Okay, simply remember, we will draw graphs in mathematics. Positive x-axis, negative x-axis, positive y-axis, negative y-axis. Remember, object should be this side always. This is the origin, optic center. In this direction, whatever we are measuring, that are negative. This direction we are measuring positive. Above the principal axis, positive. Below the principal axis, negative. These are the rules for sign convention. Okay. Next, rules to draw ray diagrams. Under ray diagrams, I already uploaded a video. Once you go through it, if any doubt. Now, lens formula. 1 by f equal to 1 by v minus 1 by u. Lens maker's formula. 1 by f equal to n minus 1 into 1 by r1 minus 1 by r2. Lens maker formula also can be asked like relation between focal length, refractive index, radius of curvatures. Refractive index, if it is there, then you should go through this formula. Focal length, refractive index, radius of curvature. Now for ray diagrams, already one video is posted. Now you practice the diagrams there. So simply I will give brief. Now when an object is placed, sometimes they will ask questions like this. For a convex lens, biconvex lens, when an object is placed at particular location, what will be the image and size nature? Like that they will ask. Now remember like this. when an object is placed at 2f2 means center of curvature. When an object is placed at 2f2, object always placed at two side, second side, and image is formed at first side. Remember that. Now when an object is placed at 2f2 means center of curvature, image is formed at 2f1, opposite side center of curvature. If you place beyond 2f2, between f1 and 2f1, between f2 and 2f2, beyond 2f1, at focus, somewhere it will be formed infinity. At infinity, at f1, between optic center and focus, f2, beyond the object, beyond the object. Okay, now when you place at center of curvature, same size of the object, same size will be formed. Beyond the center of curvature, beyond 2f2, diminished. At center of curvature, same size. Between focus and center of curvature, magnified. So first diminished, same size, magnified. At focus, we can't say which size of object it is. And between optic center and focus, magnified. All cases real and inverted, only when placed between optic center and focus, virtual and erect. Okay, in this case we can't say which shape of object is. Point object we will get. Okay, highly diminished. Nature we can't say. Nature we can't say. Okay, these are the topics related to ray diagrams. Questions related to ray diagrams. Now, focal length. Focal length of the lens depends on surrounding medium. Focal length of the lens depends on surrounding medium. It depends on surrounding medium. We have an activity when the convex lens dipped in the water, its focal length is increased. Focal length of the lens depends on surrounding medium. When it is placed in the water, when compared to air, focal length will be more in water. Okay, this is another important question. Next one, human eye and colorful world. In this chapter we have many bits, human eye and colorful world. First, least distance of distinct vision. Least distance of distinct vision. Least distance of distinct vision. Least distance, minimum distance for distinct, clear, perfect vision is 25 centimeters. Is 25 centimeters. Angle of vision. Angle of vision is 60 degrees. Is 60 degrees. Based on the structure of eye, we have many bits. Based on the structure of eye, we have many bits. What is the shape of eyeball? Spherical shape. What is the shape of eyeball? Is spherical shape. Now, what is meant by cornea? What is meant by cornea? Cornea is the now shape of the eyeball nearly spherical shape. Front portion more sharply curved. covered with protective transparent protective membrane is known as cornea. Protective membrane is known as cornea. It is the place we can see from outside. This is the place we can see from outside. The black color will be appears like dark color. Remaining this one is white. This is also from here also white. This is the portion. Okay. Now behind the cornea there is a liquid field. Behind cornea there is a liquid field is known as aqueous humor. Aqueous humor. Aqueous humor. Behind this liquid, crystalline lens is there. Crystalline lens, which is responsible for formation of image. Between lens and aqueous humor, there is a muscular diaphragm called iris. Iris has hole in the middle is known as pupil. Iris is the colored part which we see from outside. Iris is the colored part which we can see from outside. It has a small hole. It has a small hole is known as pupil. Now this lens is holded by a muscle is known as ciliary muscles. Next, at last, this is a screen where image will be formed is known as retina. The distance between retina and eye lens is 2.5 centimeters. Distance between retina and eye lens is about 2.5 centimeters. Most of the students are getting confusion here. Sometimes they are asking what is the distance between eye lens and retina. They will give options 25, 2.5, 2.27, all of the above. Something like this they will give. Now students are learning least distance of distinct vision is 25 centimeters and distance between eye lens and retina is 2.5 centimeters and getting confusion. By mistake they are keeping 25 centimeters. Don't do that. Our eye size is very small. Even our head size also, from eye to the end, head size is also not equal to 25 centimeters. Okay, remember that. Whenever they asked lens, distance between lens and retina, you just think about your eye size or your head size. It won't be 25 centimeters. So clearly, if you think, you can keep 2.5 centimeters. Okay. Next, what is the use of pupil? Through iris is a colored part. This is the pupil. Through the pupil, light will be entered inside. It has variable aperture. Very, very important. It has variable aperture. Means it controls the amount of light entering inside. When we suddenly switch off the light at night, we will feel all dark. After some time, we can see everything. Okay, when we came out from out to inside, afternoon, summer times, afternoon, when we came out from out to inside, when we came inside from outside, okay, we'll feel more darkness. After some time it will be normal. When we go out afternoon times, we'll feel more brightness. After sometimes it becomes normal. That is because of people. Okay, it controls the amount of light. When outside is more brightness, it becomes very small. It becomes very small and enters allow the sufficient amount of light. When outside is very dark, it becomes large. Pupil size becomes large and allows sufficient light. Now, if brightness is here, nighttime light. Now more brightness is there, so size becomes less and allows sufficient light. Suddenly you switch off the light. You should increase its size, no? For outside less brightness. It will take some time. Due to that, we'll feel very dark while we off the light. Then after it size will be increased, no? So we can see everything. Remember that. Okay. Next, ciliary muscles provide the accommodation. Now when we see far objects, it will be relaxed normal size. When we see objects very close, lens will be compressed. Lens will be compressed and the radius of curvature will be increases. Radius of curvature will be decreases. Radius of curvature will be decreases and focal length also decreases. Focal length also decreases. When it is in normal position, when we are seeing far objects, focal length is maximum, that equal to 2.5 centimeters. When we see closer objects, lens will be compressed by the help of ciliary muscles. Focal length is minimum 2.27 centimeters. Maximum focal length of eye lens is 2.5 centimeters. Minimum focal length of eye lens is 2.27 centimeters. Now, when this image is formed on the retina, in the retina is a delicate membrane. It consists of 125 million receptors. 125 million receptors called rods, cones. Rods, cones. Cones identify the color, rods identifies the intensity. Cones identifies the color, rod identifies the intensity of light, and it will be transmitted to brain through 1 million optic fiber nerves. Optic nerve fibers. Optic nerve fibers. These all are very, very, very important bits. We know maximum focal length of lens, minimum focal length of eye lens. We have three defects, eye defects. One is myopia, hypermetropia, presbyopia. Everything I explained clearly in the videos. Once you go through that, which are very, 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 very important for 8 marks questions. Next, power of lens equal to 1 by focal length in meters, 100 by focal length in centimeters. Power units diopters denoted by D. If power is positive, so focal length is positive. According to sign convention, focal length positive means it is convex lens. If power negative, F is negative. According to sign convention, it is concave lens. Positive means hypermetropia, negative means myopia. Next one is refractive index of prism. This is the prism, incident ray, refracted ray, emerged ray. I1, I2. I1 is the angle of incidence, I2 is the angle of emergence. R1, R2, angle of refractions. Extended incident ray, extended emerged ray, between them angle of deviation. Very, very important. Angle of deviation should be here. Okay, sometimes they will give you in the question diagram. This is the incident ray, no? This is the emerged ray. This is the refracted ray. D they will give you here. And what is the wrong in the question? Wrong in the diagram. Deviation should be measured side. Deviation should be measured side. This is the deviation. This is the deviation, changing its path. Okay, you should identify. Now this is angle of prism A. Refractive index of prism is n. When the minimum deviation D becomes capital D, minimum deviation. So when minimum deviation I1 equal to I2 equal to I we can write, R1 equal to R2 equal to R we can write. So when this situation, refractive index of prism n equal to sin A plus D by 2 by sin A by 2. A means the angle of the prism. Important. Next one is dispersion. What is mean by dispersion? Splitting of white light into 7 colors. VIBGYOR, violet, indigo, blue, green, yellow, orange, red. White light splitting into 7 colors is known as dispersion of light. Based on this dispersion, we are having rainbow. Rainbow is very important. 8 more questions. I already explained this. In the rainbow, at what angles we will get rainbow? 40 degrees to 42 degrees. Okay. Now at 42 degrees, we will get red color. 40 degrees we will get violet color. Okay. What is the shape of rainbow? Already told you, shape of rainbow is a cone shape. Rainbow is a cone shape. That cone tip is ends at eye. Ends near the eye. Next one is scattering of light. Scattering of light, when light coming from the sun, it is white color, combination of 7 colors. Atmosphere consists of molecules. These molecules are having size. These 7 colors are having 7 different wavelengths. Molecules are having different size. When white light falls on any molecule, if its size is comparable to the wavelength, that particular color or particular colors will be entered inside of the molecules. Due to that energy, light energy, vibrations are created in the molecule. Due to that vibrations, this molecule re-emits that absorbed light into all the direction with different intensities is known as scattering of light. That molecules are known as scattering centers. That light, re-emitted light is known as scattered light. If atmosphere consists of more number of nitrogen or oxygen or both, its wavelength is comparable to, its size is comparable to blue color wavelength. So blue color is absorbed and re-emits into all the direction. So sky appears in blue color. And if water molecule is present in the atmosphere, its size is comparable to all colors except blue. So all colors are absorbed and re-emitted back. So combination of all colors except blue is white color. So sky appears in white color. And even why sun appears red in the morning and evening, white in the afternoon. So morning, evening, sunrise should travel more distance due to the scattering. Molecules which are able to absorb red color are less in the evening and morning. So red color is not absorbed. Remaining colors are absorbed and scattered there itself. Red color is reaching to our eyes, so we are seeing sun in red color. So red is reaching, so we are seeing sun in red color. Afternoon time, light traveling in less distance, so we can see all the colors. Combination of all colors is white. Next one is electrical. First topic, students, very important question. Everyone should learn. I hope everyone learned already. Now based on that, we will see the bits. Open conductor, closed conductor we will discuss there. Open circuit one side, closed circuit one side. In open circuit, electrons will move in their own direction, is known as random motion of electrons. Here they will move in a specified direction, is known as ordered motion of electrons. Now here in the random motion, number of charges moving from left to right equal to right to left, so no charge. Here left to right is not equal to right to left, so some charge is there. So based on this, rate of flow of charge is known as electric current. Rate of flow of charge is known as electric current, denoted with I. I equal to Q by T, charge by time. I can measured with I. Current can be measured by using ammeter. Current is measured by using ammeter. Units ampere. Charge coulombs. Time seconds. 1 ampere equal to 1 coulomb per second. Charges will move in a conductor in a particular direction when it is connected to the source or any battery or cell. Battery or cell. So they are moving in a particular direction. So we can take drift velocity. Drift velocity means average velocity of the electrons to move from one point to another point. Average velocity of the charge while moving from one point to another point is known as drift velocity. Drift velocity for electric current I equal to NQ AVD. VD means drift velocity. VD equal to I by NQ A. Next, potential difference. Potential difference is the in the battery, in the conductor. Potential difference will be in the conductor. Remember that, in the conductor. Here electric force will act. EMF in the battery. Here chemical force will act. So here work done by the electric force on unit positive charge. Work done by the electric force on unit positive charge to move from one point to another point of distance L is known as potential difference. Is known as potential difference, denoted with V. Potential difference is the work done by the electric force on unit positive charge to move from one point to another point through the distance L is known as potential difference, denoted with V. V is work done by electric force on unit positive charge. W means FEL, force into displacement, by Q, units volts or joule per coulombs. Joule per coulombs or volts. Same condition here in chemical force. It is in the battery. In the battery, chemical negative and positive both will move. Negative charge, positive charge both will move. In the conductor only negative charge will move. So one definition here, two definitions. For example, if it is positive terminal, if it is negative terminal. Here chemical force, work done by the chemical force on unit positive charge to move from negative terminal to positive terminal is known as EMF. Work done by the chemical force, I am repeating, work done by the chemical force on unit positive charge to move from negative terminal to positive terminal, if distance is d, through the distance d, is known as EMF. Or work done by the chemical force on unit negative charge to move from positive terminal to negative terminal, positive terminal to negative terminal, through the distance d, is known as EMF. EMF means electromotive force, denoted by EMF, equal to work done by charge FC D by Q. Here we are taking distance d, here we are taking distance L. So both are same. Units also same. It is in the battery, it is in the conductor. Next, Ohm's law. For constant potential difference, V is directly proportional to I, V equal to IR, or R equal to V by I equal to V by R, whatever we can write. Ohm's law graph for constant. Ohm's law has limitations. Some are obeys the Ohm's law, ohmic materials, which do not obey the Ohm's law, non-ohmic materials. Example, semiconductor, silicon, germanium, gaseous conductors. Already I explained in the essay question, very, very important. Now electric shock. In electric shock, essay question I already explained. It is the combined effect of potential difference and electric current and resistance of the body. Very important. Electric shock. Next, resistance. Resistance means which opposes the flow of electricity. Which opposes the flow of electricity is known as resistance. It is a device called resistor. Provides resistance. Resistance units ohm. Resistance units ohm. And the resistance depends on some factors: length of the conductor, area of the conductor, nature of the conductor, temperature of the conductor. These all activities I explained. These two are very, very important. Resistance is directly proportional to length. Resistance is inversely proportional to area. While combined writing R equal to rho L by A, we will get rho is the proportionality constant, or known as resistivity. Resistivity equal to RA by L. Units ohm meters. Based on the resistivity, we can say the material is conductor or insulator. If it has more resistivity, it is a insulator. Less resistivity, it is a conductor. Series combination and parallel combination. Both are important for essay questions, and sometimes they are asking in the bits also. Series end-to-end connection. Parallel, all first ends are connected, all second ends are connected, like this. In houses we are using parallel combination. In houses we are using parallel combination. In series, current is same, potential difference is dividing. In parallel, potential difference is same, current is dividing. Now, which of the following device can be connected in the series? Like that they will ask. Or ammeter can be connected in the circuit in the series. Ammeter in the circuit is series. Voltmeter in the circuit is parallel. Voltmeter should be connected in parallel. Suppose if it is the resistor, to connect the voltmeter we connect like this, parallel. To connect the ammeter we should connect here, series. Ammeter is connected in series, voltmeter connected in parallel. Very, very important. Next one is Kirchhoff laws. We have two. First one is junction. Next one is loop law. In junction law, algebraic sum of currents in any junction is equal to 0, or sum of currents entering into the junction is equal to leaving from the junction. Loop law, algebraic sum of increases and decreases in potential difference across various components in the circuit, closed circuit, is equal to 0. Okay. In loop law, when a circuit consists of like this, V, let us take AB. Here in we are saying across various components increases in potential difference and currents equal to 0. Algebraic sum of increases or decreases in the potential difference across various components of the circuit in a closed loop is equal to 0, we are saying. For example, if it is the loop, now A, B, C, D, A, B, C, D, A is the loop. Now current flowing in in this loop, we should write equation, simple equation. I'll tell you, V. Whenever we write V, we should write. Whenever there is a battery, we should write. Whatever the name given there, that we should write directly. And whenever they given resistance and current, product of their, we should write. Current and resistors. Separately we should not write. Okay. Now we should keep the signs here. Sign plus or minus. Algebraic sum, no, either plus or minus. That is equal to 0. Now here we should remember, in the loop, we are traveling A to B, C, D, A. Now in the loop, if you are traveling A to B like this, plus to minus, final is minus, so V is minus. If you are traveling B to A, it will be plus. When we are traveling like this, it is minus V. When we are traveling like this, it is plus V. Remember that. Next, while coming to I and R, product of IR, when we take direction of current, when we are traveling A to B and direction of current is B to A, so it is plus. So our direction, current direction, same current direction, our direction same, we should take minus. Current direction, our direction opposite, we should take plus. Okay, this is about loop law. Next, electric power. Rate of power, we know, rate of doing work is known as power. Power can be written as work done by time. Okay, potential difference we have W by Q. From that we can write W equal to QV. So when we substitute there, P equal to QV by T. So Q by T we can write I, power equal to VI. And we have Ohm's law, V equal to IR. Then if you substitute this V equal to IR here, V equal to IR, so power equal to IR into I square R. From V equal to IR we can write I equal to V by R. If you substitute in this, P equal to V into V by R, P equal to V square by R. Like this we have many problems, formulas we can derive it. Next, 1 kilowatt hour. 1 kilowatt hour. 1 kilowatt hour is equal to how many joules? 3.6 into 10 power 6 joules. It is a unit of energy consumed. 3.6 into 10 power 6 joules. 36 into 10 power 5 joules also can be correct. 36 into 10 power 5 or 3.6 into 10 power 6 joules. Okay, this is about electric current. Next, electromagnetism. In electromagnetism, we have R-state experiment that current carrying wire produces magnetic field. Current carrying wire produces magnetic field, and magnetic field lines will travel from north pole to south pole outside the magnet and south pole to north pole inside the magnet. Magnetic field lines travel from north pole to south pole outside the magnet, south pole to north pole inside the magnet. Magnetic field lines are closed loops. Magnetic field lines are closed loops. Now, magnetic field lines passing through any imaginary area perpendicular to the magnetic field lines is known as magnetic flux, denoted by phi. If this area is unit area, magnetic flux passing through unit area is known as magnetic flux density. Magnetic flux density. B equal to phi by A, phi equal to B into A. Magnetic flux units Weber. Flux density units Weber per meter square or Tesla. Weber per meter square or Tesla. If this area is not perpendicular, then A becomes A cos theta. So phi equal to BA cos theta or B equal to pi by A cos theta. Now, how to find current direction when magnetic field is given? When the magnetic field is given, like this we should keep. I already explained. When the magnetic field is in anti-clockwise direction, current flowing out of the page. Magnetic field is clockwise direction, current flowing into the page. Into is there, that is into the page. Dot is there, that is out of the page. Next one, what is the formula for electromagnetic force? Electromagnetic force, when this is the magnetic field going into the page B, a charge Q is flowing with a velocity V, so magnetic force equal to QVB, product of these three. If it is not perpendicular and going somewhere direction, then it becomes QVB sin theta. F equal to QVB sin theta. If a wire is placed in the magnetic field, if L length is wire is experienced the magnetic force, then this force becomes BIL or ILB. F equal to ILB. B, if it is not in a particular perpendicular, then B becomes B sin theta. F equal to ILB sin theta. ILB sin theta. Now, motor, DC motor, it is a device which converts electrical energy to mechanical energy. Next, when a current carrying wire is placed in the magnetic field, it experiences a force that we discussed. Then it is rotating like a motor. Now, a wire is placed in the magnet, near the magnet. If a magnet is moving near the wire, then current will be generated. generated, that is equal to induced EMF equal to rate of change of flux. Rate of change of flux. Generator. Generator is a device which converts mechanical energy to electrical energy. Mechanical energy into electrical energy. We have AC generator, DC generator. AC means alternative, DC means direct. Alternative current, direct current. Here direction of current, magnitude of current directly continuously changes. Direction of current, magnitude of current continuously changes. Here it won't change, same direction. DC current is having plus and minus because positive to negative, like it will move. So direct current. AC is not having plus or minus. Sometimes it will go from one side to another side, next immediately it will changes its direction. That's why we can say it is alternative current. Okay, I hope I covered all the topics. Once you see this video and revise the textbook, I hope everyone will get good marks. Thank you for watching. Please subscribe.